Okay, so here we go. Now we're going to check whether a given solution actually works for a trig function. So when we're looking at this, does a solution actually work? Does it give us what we want to have? So they're asking us on this one, determine whether or not this one is actually a solution. So let's go over here. So what could we use to answer this question? And don't say calculator. Well, could, but that's not a real reputable way of doing it. Could I use our wonderful friend over here called the unit circle? Would that help? So let's see, just view. Okay. So as I'm looking at this here, we are supposed to determine whether or not pi over 4 is a solution to 2 sine over that. Can I go through and use our regular algebra to go and help solve this? Let's see. If I were to go and take 2 sine theta minus 1 is supposed to be equal to 0, correct? Could I add 1 to both sides? And then you get 2 sine theta is equal to 1, and then divide this by 2, divide that side by 2. So the sine of theta should be equal to 1/2, correct? So by looking at this, at the unit circle, where is theta equal to 1/2 on sine? Pi over 6. So is it a solution? The answer is, well, it doesn't appear to be. What happens if we did it this way? Try a different tactic. What happens if I took 2 sine of theta minus 1 is equal to 0? So I take 2 and I'm looking at my sine of pi over 4 minus 1 is equal to 0. Well, what's the sine of pi over 4? Go back. We take a look. Pi over 4 is here. Sine is square root 2 over 2. So that means I have 2 times square root 2 over 2 minus 1 is supposed to be equal to 0. 2's cancel out. Square root of 2 minus 1, is that equal to 0? No, can't happen. So that's not going to work. Now, by going through and doing it the way we had done the first time, that also goes and identifies or helps us identify what would be the solution. So when we were taking a look at this and we said the sine of theta had to be equal to 1/2, we had said that theta was going to be equal to pi over 6. So there we go. Seems simple enough, doesn't it? Let's try something else. Now, what about this one? I want to go through and solve this. Oh, that looks fairly easy. Where is the cosine of theta equal to 1/2? I look here, cosine is the x, x is 1/2 here at pi over 3. Ooh, good. So that must mean that theta is equal to pi over 3. That's it, all done, right? Huh? You're right. There is more. Because when I look at this also, sine is x. X at 1 is at, where were we at here? 1/2, right? Is that what we're looking for? I just spaced that off. I got an x down here at 1/2 that says it's at 5 pi over 3. True, that's if I'm looking at the inverse of it, but I want to know where the cosine of theta is equal to 1/2. So that means theta could also equal 5 pi over 3, and I would also get 1/2, correct? Okay. Is that all the answers? But I'm waiting for you, for Herr Gage to tell me. You betcha. What happens if we go around the circle one time? Well, if I go full around the circle, that's another 2 pi. So if I go and add on a 2 pi, which in this case would have to have a denominator of 3, so it'd be 6 pi, that would be 7 pi over 3. Yes, it is infinite. Okay. What we would want to do is we are going to identify the initial condition, and then we are going to identify how often it appears. So, as we are looking around on the unit circle, now this is where taking a look at it on the form of a cosine or a sine wave would also help. But if I find it that it hits my 1/2 at pi over 3, where will I get this again? Well, if I go around the circle another time, will it hit it? Will it hit it? And it just keeps hitting it and hitting it and hitting it. So this is going to be plus 2 pi k. And k is an integer. Okay? So I could put any integer in there I want, and I'll come up with it. Now, mind you, this also means that I could go backwards. If I started here and I kept going around and I kept going backwards through it this way, I would still be hitting it one day. So that is why the k is going to be there. So now this one here, would it also be the same thing? 2 pi k, or you might see it written as 2k pi. Either way, it does the same thing, where k is an integer. Okay. That's it. That identifies every single possible solution that can be available for this. Okay. Now, mind you, when we're looking at this, we're really only going to be looking at things that are between 0 and 2 pi, because everything else is redundant. Okay. But we need to understand that that is going to be the case. So let's try another one. Aren't these fun? So solve this one. Now, for this one, they're telling us, hey, we're just going to keep it between 0 and 2 pi, no big deal. So I want to figure out where this is going to be. Now, this is my preference for it. I would go through and subtract square root 3 to both sides. So I'd get 2 sine theta is equal to negative square root 3, and then divide by 2, divide by 2, so I have the sine of theta is going to be equal to negative square root 3 over 2. Now, I want to go and identify where in the world I get negative square root 3 over 2. So I go back to the unit circle. Do I see a sign that is going to be square root 3 over 2? Pi over 3. So square root 3 over 2, but it's got to be which kind? negative. So it would end up having to be down here at 4 pi over 3, right? And 5 pi over 3. So that means theta can be equal to 4 pi over 3, 5 pi over 3. So those are our solutions. It's not that big of a deal. It's just going to be there. Okay? So let's try another one. Let's see this. Now this one's moving things up again another notch. I want to know where the sine of 2 theta is equal to a half. Whoa. That's not cool, is it? We're only accustomed to thinking of what is the sine of theta equal to 1/2. Well, my question is, where is the sine of theta equal at 1/2? Pi over what? Pi over 6. So if theta is equal to pi over 6, this works. Is there another one? Of course there's another one. 5 pi over 6. So these are the possibilities. Now, you can use a different variable in here to help you out. But I want 2 times that. So that means that this over here, if I'm really looking for the theta, and I suppose I should have used something like, I hate Greek letters. I was going to put in an X, X, and an X. Okay. So now I want to know where 2 theta is equal to pi over 6. I want to know where 2 theta is equal to 5 pi over 6. Well, in order to do this, we would have to divide or multiply both sides by the reciprocal of 1 over 2, correct? This would get multiplied by 1 over 2. So we're 1 over 2 here and 1 over 2 here. Is that better? Not much, but it gets you there. So theta would end up having to be pi over 12. Theta would have to be equal to 5 pi over 12. Okay. So because theta is between this, we would be done. Now, I noticed in the book there, it says that they wanted to write the general one of these, you'd end up having to add in the 2k pi on there if you wanted to identify all possibilities. But this is where that goes. It's not bad. Let's try another one. What about this one? Okay, let's think about this. Where is the tangent of, say, x equal to 1? Now, tangent is sine over cosine, correct? So that means sine over cosine would have to be exactly the same. So that means our x would have to be what? Pi over 4, and x could also be at 5 pi over 4. Okay, so we've got those, correct? Does that make sense? Are you sure? Absolutely positive. Pi over 4, sine over cosine, so that's going to be positive there. Yep, that's fine. And then this one was down here at 5 pi over 4. Yep, so okay, good. So now that means that I have to get my theta minus pi over 2 is equal to pi over 4, correct? So theta minus pi over 2 is equal to 5 pi over 4. Well, that means that I got to add the pi over 2, add pi over 2. But if I add pi over 2, that's not going to work for me very well, so I got to go 2 pi over 4 with the common denominator, correct? So this is going to be 3 pi over 4. So I add on my pi over 2 here, which would be 2 pi over 4 for the common denominator, and I end up with 7 pi over 4. Okay? So those are the three possibilities, or the two possibilities that fit that condition. Okay? Make sense? Now, one of the things I want you to sit here and think about is be careful when it comes to tangent. Tangent has a period of pi, okay? Not just 2 pi. Okay? Granted, I can write each one of these down here with a 2 pi and it would still work. But because of the way tangent operates, its period is a little quicker. So, let's try it this way. They want us to go now and take a look at it using the calculator. So yes, we can actually use calculators at times. So, I grab my calculator. Reset it. Now it says express any solution in radians, so we want to make sure that we're keeping it in terms of radians, which is fine. So, where is the tangent of theta equal to -2? So, we go second, inverse tangent of -2, close it, and what do I get? I said -2, close it, and I end up with that value. So it says rounded to 2 decimal places, so I would end up having to go to just there, -1.11. Okay. Is that the only place that it could happen at that tangent would be at -2? So, this is where talking about tangent x, we're going to graph this out here once real quick. Window, yeah, I can leave that like that. We'll go from -2 pi, 2 pi. And leave those at 10 and -10 graph. Okay. So there's my tangent function. And now I was looking at it where it was at -2, correct? So I'm just going to put in my -2 down here and graph to see where my intersections are going. So we were supposed to do this between 0 and 2 pi. Now the first one we came up with, Trace, was at -1.1, correct? That was the first one because of the way the inverse works. Where is the next one going to be? Well, the next one should be over here. How much farther over is that? Would that be another pi? So if I were to go and take my -1.1 and add 3.14 to it, should I end up in the same place? And the answer is yes. So, does that make sense? Yes? No? Yes, no? Maybe. We are trying to find where this thing is going to be at. Yes, sir. Yes, Andrew. What was the question again? But it's just another way of coming up with a value. The problem with the unit circle is it's only identified out in specific places. Okay, the calculator can provide you a lot more possibilities. Okay? So, but I'm still waiting for you to notice one thing that isn't quite right yet. What was where was our, let's see, domain supposed to be? 0 to 2 pi. So is it legal for me to use that answer of negative 1.11? And the answer would be no, I can't get by with that one. So is there another one that is within that range? Well, it would be sitting up over here, correct? So if I were to go and take negative 1.11 and add on to it, say 6.28, which would be 2 pi, I would end up at 5.17. So when you're looking at the solution set and it says it's between 5.17 and 2.03, you have to be careful because the calculator gives it back to you in the domain of the negative or the inverse function. So when you're looking at it up here, you have to be mindful of that and adjust for all the possibilities that are there. Now, it says express any solutions. So now we have to go and take this one step, well, right between 0 and 2 pi. So if I had to go and move this out anymore, I would end up putting the plus, 2k pi on it if I needed to. Okay. Quadratics. So I'm taking a look at this in terms of quadratics. Even more fun. Okay. Do our rules of quadratics apply here? And the answer is yes. Now I am going to show you a little bit of a, well, I kind of used it a little bit now, but by going through and doing a substitution on this, it'll make this a by far simpler problem to work with, because right now 2 sine squared minus 3 sine plus 1 just looks flat out ugly. But if you only had this to deal with, 2x squared minus 3x plus 1 equals 0. Is that easier to work with? Yeah. So basically what we're doing here is we are saying that, hey, x is equal to sine theta. We're just doing its replacement. It makes it to a lot simpler of a problem. So we know how this thing is going to factor out, then it's going to be equal to 0, obviously. And let's see, we've got an x here, we've got an x here. Both of these are negative. This has to be a 1, that has to be a 1. And so does it matter where the 2 goes? The answer is no. So the 2 can go in either one of these places. Just double check. 2x squared minus 2x minus x gets us to the minus 3, and away we go. So now I can go and take this down to the next step that says 2x minus 1 is equal to 0, and that x minus 1 is equal to 0. So here, x is equal to 1. Here, x is equal to 1/2, correct? But what is really x? Well, x is really sine theta, correct? So that means that here the sine of theta is equal to 1/2. The sine of theta is equal to 1. So now we can go back, use the unit circle, and identify where these possible values are at. So where is the sign equal to a half? Well, theta is equal to pi over 6 and 5 pi over 6. Where is sine equal to 1? Pi over 2. So theta is equal to pi over 2. So that means that these are going to be the solutions for that particular problem. Nothing different. It's just that we do that substitution, bring the sign back again, and we answer the question. So, sort of kind of makes sense? Yes, no, maybe so. Just because I like you guys so much, let's move it up a step. Huh? I would assume then that you guys don't want me to like you so much. So, okay, this is just looking flat out ugly, is it not? Okay. One of the things that we always want to do is make sure that it's written in one variable. I got cosine, I got sine here, so this is just, have no fear. Identities are here. See how I did that? Yeah. Sine squared is also equal to 1 minus cosine squared theta. Okay? Remember, sine squared plus cosine squared is equal to 1. So by use of that identity, I can go and deal with this. So now if I go and set x is equal to cosine of theta, I get 3x plus 3 is equal to 2 times 1 minus x squared. Have I just simplified the problem immensely? So that means that I'm looking at 3x plus 3 is equal to 2 minus 2x squared. Do I need to go through and do the rest of the quadratic solving? You guys are pretty good at that, right? So suffice it to say, it works out to this. Cosine of theta is equal to a negative 1/2, and cosine of theta is equal to negative 1. So the question comes, where do you get cosine of theta equal to negative half? Pi over 4 pi over 3. And 2 pi over 3. Where is cosine equal to negative 1? Pi. So there we go. There are solutions. Okay. But keep in mind that cosine squared plus sine squared is equal to 1, and you will be fine. So, there you go.